wonderful students. I welcome you to another very interesting chemistry class. This is Eko Learners Support for WAEC and NECO candidates. I am your humble chemistry instructor, Rashid Jimon. Are you ready? Let's dive in.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Today, we are looking at a very important topic, okay? And that is valency of elements. This is one of the fundamental topics that you, as a chemistry student, must understand because so many reactions are dependent on this topic. So I need you to take your pen, take your notebook, write the topic down and today's date. The topic again is valency of elements. We have set the following objectives to guide our instruction. 1, at the end of this lesson, you will be able to understand the concept of valency and its importance in chemical bonding. 2, you will be able to determine the oxidation number of elements in compounds. 3, you will be able to apply the concept of valency and oxidation number to real-world examples. This video is going to be in 2 parts. The first part is the valency. The second part is going to be the concept of oxidation number. Let's get going. But before we go, let's look at some keywords that we would need to understand to use in learning this very important topic. Number 1 is valency. What is valency? Valency is actually the combining power of an element. We're going to talk more about that as we continue. Oxidation number, it is the charge on an ion. Electron, of course, is one of the subatomic particles. The others are proton and what? Neutron. You're amazing. And lastly, valence electron. What do we mean by valence electron? It is actually the electron, the number of electrons on the outermost shell of an atom. I believe that you have written down all of these keywords as they will be very instrumental in you understanding this topic. Wow! Let's start with an icebreaker activity. And suppose you went to a party, a birthday party, and you have circle of your friends that you have to give a handshake to. Okay? Now think about how many hands you will need to shake to form a group handshake. You're transmitting the joy, the energy, the love that you have to your friends. This is exactly what atoms do. And this is how they come together to form bonds. Let's look at an inspirational chemistry quote, which says that chemistry is the study of transformation. Okay? Chemistry is the study of transformation. It helps us to understand the changes that occur in our environment. And that is why it is such an important subject. These are the contents for this particular lesson. We will look at the introduction. We'll answer the question, what is a valence electron? We'll look at orbitals and their different types. Differences between valency and oxidation number. I'm sure you're really wondering, is there really a difference? You'll find out shortly. And lastly, you must stick and stay to the end of the video so that you do not miss our top 5 exam questions. Let's go. Do you have a copy of the periodic table? You should pause this video right now and get a copy because you will need the periodic table as a guide for what we are going to be discussing today. If you look at the periodic table, it is a table of elements that are arranged in order of increasing atomic number. You are going to learn about the periodic table in separate videos. Now, you have learned about the structure of an atom. Okay, so many postulates and models of an atom, but the one that is very common is the Rutherford's model. Okay, we describe an atom as a sphere, which has what? The center, which is called the what? The nucleus. Okay, so that is the nucleus. The nucleus, that is the core of the atom. And then you have particles contained in the atom. In the nucleus, there are two particles. You have the proton as well as the neutron. Both of them are contained in the nucleus. But on the orbit, or what we call shell of an atom, you have this very important particle, which are what? Electron. My dear student, I need you to know that chemistry, it's all about electrons, because electrons are responsible for most chemical reactions, unless when we're talking about nuclear reactions. And so, your focus must always be on this very important particle, which is the what? The electron. You are amazing. Know this fact, and you will be on your way to excelling in interpreting chemical reactions. Now, since we're talking about elements, fundamentally, you should know the first 20 elements on the periodic table. And this is very important. So I'm asking you to recite the first 20 elements. You must know this. But if you don't, wow, why don't we do it together? Are you ready? Okay, let's go. It's going to be in form of a song. Come with me. So, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. Oh, how did that go? I want you to learn that song because you will need to know, at least for now, the first 20 elements. Very good. Now let's move on. Let's move on now. Now, so let's consider atoms of hydrogen and helium. And both atoms are actually given here. So apart from the fact that these two atoms have different electrons, hydrogen have 1 electron, helium has 2 electrons. And apart from their structure, okay, what other difference can you observe between an atom of hydrogen and helium? Please take a look at the two of them. Wow, did I hear you say that hydrogen is reactive? That is amazing. You're right. Hydrogen is chemically reactive because if you look at an atom of hydrogen, it only has 1 electron. So the first shell, which is the K shell, is incomplete. And so hydrogen has options of either having to lose the 1 electron or having to share another electron with any other atom or with itself, okay, to be able to complete that shell. But on the other hand, helium cannot do the same because the requirement is that the first shell, which is the K shell, should have a maximum of 2 electrons, and that's exactly. So helium is stable, and so it is chemically unreactive. Please take note of that. Helium is one of those elements that are chemically unreactive. Can you give me other examples of elements that are chemically unreactive? Fantastic job. Argon, neon, krypton, xenon. In fact, all the noble gases are referred to as being chemically unreactive. You're really doing well with the class so far. Well done to you. Okay, so how many electrons can a shell hold? That's the question I'm asking you. Yes, we have looked at an atom. It contains the proton and the neutron, which are in the nucleus, and the electron on the orbit. But how many electrons can the shell actually hold? Now imagine that you have a jar of candies and you're asked to, please yourself and take as many as you would like. I'm sure you would like to take many, okay? So, but that is not the same for electrons. There are actually maximum number that the electrons can, that the atom, the shell can actually accommodate, okay? So we are going to look at those numbers together now. We have this table here, shell number 1, 2, 3, maximum number of electrons. So the shell with shell number 1 is designated with the letter K. Let me pick my pen. It's designated K. That is the K shell, is the first shell. And then we'll follow alphabetically like that. Okay? The second shell will be what? L. The third will be what? M. The fourth will be what? N. And it goes on like that. So just alphabetically. Now, can we then calculate the maximum number of electrons that each shell can hold? Now, to be able to do that, we use this formula, okay, which is 2n squared. I want you to write this down in your notes. 2n squared, okay, where n there, okay, is the number that you have here. So suppose you have when n is equals to 1, and you are applying that formula 2n squared. Okay, so this is going to be what? 2 in the bracket of n here is 1 squared, and that will be 2. 1 times 1, 1 squared is 1, and that's 2 times 1, 2. Meaning that the maximum number of electrons that the K shell can hold is what? 2. Simple. Wonderful. Okay, can you then use this same formula to fill up this table? I want you to pause the video right now and then complete this table, and let's find out how you fare.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Welcome back. So, how many electrons can the L occupy? How many can it accommodate from what you have written down in your notes? Amazing. 8. That's correct. How about the M? Okay. What did you arrive at? 18. Wonderful. And how about N shell? Okay. 32. This is well done. And I want you to give yourself some cheers. You're really amazing. Now, these are the maximum number of electrons that each shell can accommodate. But there is a global convention that apart from the first shell, okay, which accommodates only 2 electrons, we assume that the other shells can hold maximum of 8. Even though the actual number of electrons they can hold are 8, 18, 32, and the likes, it's a general convention that apart from the first shell, which is the K shell that can hold 2, others can hold 8 electrons, because we're going to be making use of this as we go on. And you can see there, okay, the K shell has 2 electrons and it becomes very stable once you put 2 electrons in it. How about the other shell, the L, the M, and the N? Okay, they can hold maximum of what? 8 electrons to become stable. This is what we call duplet configuration here. Duplet. Can you say that again? Duplet. Okay, di means 2. Okay, and this other one that can hold 8 electrons, we refer to that as what? Octet configuration. The word octa in Greek means 8. Octagon, 8-sided shape. So octet configuration. Don't forget, this is usually the aim of all atoms, to be able to achieve either the duplet or the what? The octet configuration. Really, really amazing. Let's move on. Okay. To erase what is on the screen, and then let's move to the next slide. Very good. Then valence shell and valence electrons. Electrons in an atom are arranged in definite shells. We have already looked at that. The K shell, the L shell, the M shell, the N shell, and all of that are indicated here. The last shell of an atom is what we refer to as the valence shell. The last shell. So if you look at the diagram here, okay, this is going to be our K, this is going to be our L, this is going to be our M. The M is the last shell, and so it is referred to as what? The valence shell. Another name you can call it is outermost shell. Okay? And the number of electrons contained in it is what we call the valence electrons. So the valence electrons are contained in the valence shell. If I may ask, how many valence electrons are in the atom that is displayed on the screen here? Can you count? This is 1, this is 2, 3, 4, 5, 6, 7, and what? 8. It means that this particular atom has 8 valence electrons. If I may quickly ask, what does that make that atom? What type of element is that has 8 electrons in its outermost shell? Bravo! You are correct. That is the noble gas. That is the noble gas because that signifies octet configuration. Amazing, amazing. Give yourself some cheers. Okay, let's move. All right, we have this question. Are shells the same as orbitals? The answer is no. Orbitals are different. And what is an orbital? An orbital is a region of probability where an electron can be found. Okay, for example, where can I find you? You probably say in your house or in your school. Yes, where you can find an electron located, okay, is what we refer to as orbitals. And there are different types of orbitals. So we have the s orbital, yes. We have the p orbital, we have the d orbital, and we have the f orbital. And their shapes, you may be asked in the exam. So let's look at the shapes of these various orbitals. Let's start with the s orbital. The shape is a sphere. The s orbital is a sphere, or you can simply say it's spherical. Okay? The p orbital has a shape that is referred to as dumbbell. Can you say that? Yes, dumbbell. That is the shape of the p orbital. Okay? This is where you have most of the p block elements. Okay? Dumbbell. Then the d orbital, which are the transition elements, they have a more complex shape that we'll describe as double dumbbell. That sounds like a rhyme there. Double dumbbell. Okay? All right? And you can see that the d orbital actually has 4 lobes there. 1, 2, 3, 4. There are 4 lobes on the d orbital. While for the f orbital, where you have the lanthanide and the actinide, there are 8 lobes there. If you count the number of lobes there, there are 8 lobes. And the shape is a more complex shape that we describe as multiple lobes. We describe them as what? Multiple lobes. So these are the shapes of the different orbitals. Now, how many number of electrons can we have on the orbital? Now, to be able to do that, we use this formula, which is 2 times open bracket 2L plus 1. Okay? Now, where L have these whole numbers, if you insert these whole numbers into the equation or formula there, you are going to see that the maximum number of electrons for the S is 2. For the P, it is 6. For the D, it is 10. And for the F is 14. I hope you are able to navigate your way using the formula, but that's exactly what you are going to arrive at. Well done so far. Let's move on. All right, what is a valency now? A valency is the combining capacity of an element. As you can see here now, this particular atom, sodium, there is transferring one electron, and that is being gained. This is chemical bonding in play there. That is what valency is. When element comes together, the power that they use to form bond is referred to as the valency, and is the number of electrons an atom can share, lose, or gain to form bonds. As you can see here, okay, in order to achieve either duplet or octet configuration. So you can see there sodium and chlorine, okay? So because sodium is losing one electron here, definitely its valency is going to be 1, and that of chlorine is also going to be 1 because chlorine is receiving 1 electron. Mind you, there is a difference between valency and oxidation number, and that's what we are going to look at in this table. So I need you to take your note now and write down the differences between valency and oxidation number. This is usually a misconception among students that they are the same thing. They are not. Valency is different from oxidation number. You can see that valency 1 there, it is the number of electrons lost, gained, or shared by an atom, while oxidation number is the charge on an atom. That emphasis has to be made. Valency does not have a sign. So for example, the valency of sodium is 1. The valency of chlorine is 1. But when you come to oxidation number, the oxidation number of sodium in most of its compounds is +1. That of chlorine is -1. You can see that charges are now brought in when we talk about oxidation number. Valency is always a whole number, but oxidation number can be a fraction. For example, the oxidation number of potassium superoxide is -1/2. So that is allowed when we come to oxidation number, and the other differences that are clearly stated here in this table. Now, the valency treasure hunt. Okay, now I want you to imagine that you have been given a task to look for a treasure. So everybody is supposed to get 8 cowries. Okay, and once you're able to do that, you become happy. So this is the treasure that you and your friends are going to explore. And let's see how you're going to use this to be able to learn the valency. Now, you're welcome back from that treasure hunt. Now, at the end of that treasure, let's say that we have a scale, and that scale starts from 1 and it ends at 8. The midpoint is 4. So we have 2, we have 3, we have 5, 6, and 7. Now, suppose at the end of that hunt, treasure challenge, you met your friend and you asked, "Oh boy, how far? How many calories have you been able to get?" And your friend said, "Wow, I tried, but all I could get is just 1 calorie." So your friend is here. And your friend turned to you. "Oh boy, how far? How many were you able to get?" You said, "Wow, I thank God I was able to get 7. So you are here. Now, the time for the challenge to end is drawing nearer. Both of you have to make a decision. What do you think you can do? Who is going to make compromise between the two of you? Okay? Do you think that it will be easy for your friend to give you his own 1 electron so that you can get up to 8 because this is the destination, this is the promised land? Or will it be convenient for you to give all the 7 that you have labored for to your friend so that your friend can get to the promised land? You agree with me that the easier thing to do is that when an element is not even halfway to the destination, okay, what it will usually do in that case is that it will give up. And that is why atoms that have 1, 2, or 3 electrons usually give up their electrons because they are far away from the promised land. When they do so, that becomes their valency. So because they are losing, they will have a valency here 1, here 2, here 3. Now, but atoms that have been able to cross to the other side, they hardly want to lose the treasure that they have been able to get. Instead, they hold on tight to what they have and they wait patiently for somebody to donate to them. And so because this particular atom will still need to gain 3 more electrons, it's going to have a valency of 3. This will have a valency of what? 2. This, that's where your friend is. It will have a valency of 1. What do you think will be the valency of somebody who is able to get 8 of those cowries? Fantastic. That's a very good answer. E's valency is going to be 0. Why? Because that is the octet configuration. And you can see here that all the atoms that have 1, 2, or 3 electrons, they usually lose such electrons and they are the metals. While those who have 5, 6, or 7 valence electrons usually gain more to complete that shell, and they are referred to as the non-metal. And you can see the valencies of at least the first 20 elements are stated here. So I want to believe that you should be able to determine the valency of elements by now. Okay, let's move. So very quickly now, we want to learn how to calculate valency of elements, and we're using this table. So let's go. That's hydrogen, the atomic number 1. Okay, so the K shell is going to contain how many electrons? 1. What electron would the L contain? None. The M, none. This, none. And so its valency is going to be 1. I'm just going to do up to boron, and I will trust you to be able to complete this table and leave your comment in the comment section. So let's go. Helium has 2 atomic number. So in the K shell, it's going to have 2 electrons there. In the L, no electron. In the M, no electron. In the N, no electron. And so its valency is 2. Okay, let's look at lithium. How many electrons is it going to have in the K shell? It has 3 atomic number. No, that is not correct. You cannot have 3 electrons in the first shell. It can only hold 2. So 2 is going to go here, and the other one is going to go there. All right? There's no electron here, no electron here, and you can see that clearly there that 1 electron is in the valence shell. And because 1 is less than 4, which is halfway to the promised land, so definitely the valency is going to be 1. Let's do for beryllium with atomic number 4. That will be 2, 2, no electron, no electron. 2 is still less than 4, and the valency will be 2. All right, for boron, this will be 2, 3, no electron, no electron. 3 is still less than 4, and the valency will be 3. So I want you to use this magic to complete the table for the first 20 elements. I believe that you'll be able to do that. Now let's look at our top 5 exam-styled questions. Number 1, when metals react, they do so by what? We have spoken about metals and non-metals. How do metals react? A, gaining electrons. B, sharing electrons. C, donating electron pair. D, losing electron. What is the correct answer? Did I hear you say losing electrons? That is fantastic. Metals lose electrons to complete their shell. Let's go to the next question. Elements in the same group of the periodic table have A, the same number of valence electrons, B, the same number of electron shell, C, different chemical behavior, D, the same atomic size. What's your option here? What's the correct option? Yes. A, the same number of valence electrons, B, the same number of electron shell. That is a bit confusing, all right? But the correct answer is A. They have the same number of valence electrons. For example, in group 1, where you have lithium, sodium, potassium, each of them have 1 electron in their valence shell. Okay? So the correct answer here is option A. Let's move to the next one. Element X has 2 electrons in its outer shell, while Y has 6. What is going to be the formula of the compound that they are going to form? Okay, so the smart thing for you to do here is simply to electrons. X has 2 electrons. Yes, the valency is 2. Y, the element Y has 6. Okay, and that is 6 electron is going to be what? It needs to gain, yes, that is going to be 2, 4. That's right. Yes. Yes. 2, 4. Okay, and so X will take 4 and Y will take 2. X 4, Y 2. The option is not among the option, but that is the right thing to do. Okay, to write the electrons, okay, of each of the atom and exchange them. The answer is not in the option. Let's look at the next one. Let's look at the next one. Valence electrons or dash. So you are supposed to pick any of these to complete the gaps there. Valence electrons or dash electrons. What's another name for valence electron? The correct answer here is outer or outer electrons. Are most important as they participate in what? Look at the options. They participate in bonding. In bonding, yes. The dash states that, okay, that is what we call the octet rule. The octet rule states that atoms lose, gain, or what? Or share electrons. Okay, to have field energy level. This gives atom a stable configuration like those of the noble gas. Okay, so with this we have come to the end of our top 5 exam style question. Yes, we have one last one, which is the true or false. Valency and oxidation state of an element is the same. Is that true or false? The correct answer is false. They are not the same. So you press the false button there, which is the red one there. So these are some common mistakes that students make in this particular topic. And don't forget that valency is all about combining power, as you can see on the screen there. Okay, we have looked at valency and oxidation number, meaning different things. We have looked at valencies of metals to usually be 1, 2, or 3, and those of non-metal to be 5, 6.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
6 or 7. So I thank you very much for your patience in going through learning about valency. I want to enjoin you to leave your comment, your suggestion, whatever discovery that you have made, leave it in the comment section as we meet again in the next class. Don't forget to always continue to develop and improve on yourself.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback.